So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass coder this side. So we are going to solve the problem array to BST today, right? And the problem is actually very simple. The problem statement is actually very clear. The problem statement says you have been given a sorted array. You have sorted array in your hand, and you have to return me a height balanced BST. Height balanced BST. Now we all know what is a BST. BST means a binary search tree, which is a binary tree where the value of the every left node is less than the value of the node, and which is in turn less than the value of the every node in the right subtree. Now what do you mean by height balanced? Height balance says that add one more property in the BST, that height of left subtree I'm asking, right? Height of left subtree minus right subtree, like height of left subtree minus height of right subtree, absolute value is always less than equals to 1. It should never be equals to 2 or more. It should be always less than equals to 1, right? So you will make a height balance BST, right? So suppose a structure something looks like this structure, like left subtree for this node is height is 2, but the right is 0. It will return 2 minus 0 equals to 2. But this is not a valid height balance BST. But if the structure looks something like this, then this is a BST, because every node is following the height balancing property. It is also a correct one, right? It is also a correct one with this and this. Now also it is correct, right? Okay, so these are the properties of height balance BST. But how will you make a height balance BST from a given array? How will you make a height balance BST from a given array? So suppose the array given to you is 1 connected to 2, 3, 4, 5, 6, 7. These are the values you need to insert into the BST, right? Now how will I do it? So my first task is that I know that if I want a height balance BST, the root should be the middle value. Root should be the middle value. How am I able to decide it? Just the conclusion that if I want equal number of children on left side, equal number of children on right side, then middle value should be the one I should go for, right? Now, in the case of odd elements, in the case number of odd elements, you can see 1, 2, 3, 4, 5, 6, 7. There are odd elements. I can simply choose the n by 2th element, right? Because there exists a middle. I can choose 1, 2, 3, 5, 6, 7, right? But what if the array given to me is 1, 2, 3, 4? Which element should I choose now? So I can choose either 2 or 3. That is my wish. That is properly my wish, right? There is no distinction in that. Now, suppose I choose 4. Suppose I choose 4 as the root and I make a node 4. This is my answer node, right? This is my correct node. Now what happens? I know because 4 is my root, 1, 2, 3 should be lying here on the left subtree, and 5, 6, 7 should be lying on the right subtree, right? The problem exists the same. That is, I just made an array of size 7 into the problem of size 3, right? So size 7 problem is now shifted to 2 into size 3 problem. The problem is exactly same. This will also return a tree which will be connected to its rightward. This will also return a tree which will be connected to its leftward. So it is just a simple divide and conquer approach. I hope you are realizing that. Divide and conquer approach, and we are using recursion to solve it. Recursion we are using to solve it. Right? Okay, so same one for 1 to 3, what will be the middle element? It will be 2. So insert 2. 4's left will be 2, and similarly 4's right will be 6. Now we know because 1, 2, 3, 2 is inserted. So 1 has to come on left, 3 has to come on right. Similarly 5 has to come on left, 7 has to come on right. So what will I do? I will just make them. So 1 here, 3 here, 5 here, 7 here, right? So what happened is I created something like this. Suppose I marked it as low, my marked it as high. I marked it as high. So I found the value of mid. I made the node. Now my left subtree is made for the value of low to mid minus 1, and my right subtree is made from the value of mid plus 1 to high. Are you realizing what I'm saying? Are you realizing? That is, if I made the mid as root, these three values are gonna be from low to mid minus 1, and these three values are gonna be for mid plus high, mid plus 1 to high. What is the base case of this recursion? Simple. If low is greater than high, return null. And if it is equals to high, return the new node only, because the left and right, if it is equal, that means this condition only one node is present, so just make it and do not go for left and right, because they are obviously going to return null. So return new node with what value? Low value, because there is only one element, so ARR of low, right? What is the whole pseudocode? Let me tell you, right? So suppose this is my driver function, the main function given to me by GFG, right? So suppose it gives me nums array. What will I do? I will say n equals to size of nums, and then return the solve function, which takes in nums array the index low index, that is 0 from n minus 1. That is, it is covering whole range of 0 to n minus 1, right? Now let me implement the solve function. So solve is taking my array, my low, my high, and what is it doing? If low is greater than high, return null. You have to return null, right? If low is equals to high, return new node with value of IRR low. I hope that is clear to you. Otherwise, what do? You say root equals to new node. Let first mid is equals to low plus high by 2. Okay, mid equals to low plus high by 2. New node of ARR mid, and now root left is equals to solve for. Now the low is going to remain same, but the high is going to be mid minus 1. And similarly, root right is going to be solve for mid plus 1 up till high, right? And at last return the root. That will be your answer, right? I hope you don't find it difficult, because actually it is very easy, right? It is not a thing to solve. Now the only thing you need to crack is that for a given list you will have to pick the middle element. Okay, now let us try to go to the code and just code it down real fast. Hope you are excited. So here is the coding section, guys, but before starting with it, I would like you to subscribe to my channel, because it really motivates me, right? So what will I do? I will say int n equals to nums.size, and now simply return the solve function for nums starting from 0 going up till n minus 1, right? Now what do? Just say node star solve, because it is returning a node, vector int and nums, int low, int high. What is int low and int high? It is a range. So if low at any point becomes greater than high, return null, because you have exhausted this side of the array. Otherwise, if low is equals to high, just return a new node with the value of nums low. Otherwise, make a new node. So node star root equals to new node with ARR of, now you need a value. So int mid equals to low plus high by 2, and it is not ARR, it is nums. So nums of mid, right? Now roots left is gonna be the recursion call for solve nums. It will go from low to mid minus 1. Why mid minus 1? Because mid has already been made a node. Root right is gonna be solved for nums mid plus 1 up till high, and simply return the root. That's all. Let us try to compile and run it. Hope it will work fine and will not give any error. Okay, it is working fine for the sample test case. Let us try it for the submit as well, and it is working fine. So thank you for watching. You can see I have completed my 223-day streak. Hope you are doing well too, and we'll meet again in the next video. Till then, stay tuned and keep coding. Thank you. Have a nice day.